Welcome. In this video we are going to implement non-maximum suppression in Python. But before starting, let's have a look on what the non-maximum suppression is. In object detection, non-maximum suppression, or in short NMS, is a technique used to select the best bounding box out of multiple predicted overlapping bounding boxes. Now let's say we have an image like this and we want to perform object detection. So we take an object detector, we run the inference, and as a result what we get is this. Now looking at this picture, we can easily understand the problem. For a single detected object there should be a single bounding box, but many times we get multiples of them. This happens because most of the object detector take a very common approach in which they employ the sliding window over the feature maps and generates multiple bounding boxes. Now what we need is to somehow filter out the best one out of them. And this is exactly where NMS comes into picture. But before discussing it, I would like to discuss another important concept which NMS algorithm utilizes. That is intersection over union, or in short IOU. IOU is a matrix which is used to quantify the percentage of overlapping between the two bounding boxes. In mathematical terms, it is the ratio of the intersection and union between the two bounding boxes. Now consider these two bounding boxes. The overlapping area is their intersection, and all of the area they together occupy is their union. So by dividing the intersection area by union area, we can easily find the IOU between the two bounding boxes. Now let's talk about how does NMS algorithm work. The objective of the NMS is to select the best bounding box for the detected object and to remove all other bounding boxes. And to do this, it takes into account two things. Number one, the confidence score associated with each bounding box. Number two, IOU of the bounding boxes. The working procedure of the NMS is simple. First of all, it takes all the bounding boxes and figure out which one has the highest confidence score. In this case, this box has the highest confidence score. Let's call it box A. After this, NMS check whether the IOU between the bounding box A and other bounding boxes is greater than a certain defined threshold or not. Now let's say this threshold is 0.5. So when it's found for any bounding box that the IOU is greater than 0.5, then it simply removes that bounding box. This process runs iteratively until there is no more reduction of boxes possible. And in the end, we get only the best bounding boxes with highest confidence score. This is how NMS algorithm works. Now let's implement this algorithm from scratch to see it's working. So let's get started. To implement the NMS algorithm, we need to keep in mind its working procedure, and that's why I have already written them in steps here. But before implementing these steps, we have to perform object detection. And for that, I have a separate file where I have written the code to implement object detection using YOLO v5 and OpenCV. I am not going in detail of how this code is working because I have already made a separate video on it. If you are interested in the explanation, then you can watch that video. I will also share the link in the description. And further, if you want to use the same code and same object detector, then again you can find them at the link given in the description. And by the way, you do not need to use the same code. You can also use an object detector of your choice. The code for the NMS which we are going to write will work in most of the cases. Now let's come to the topic, and if I run this code, here you can see the results. We have only one object in this image, which is car, but if you notice, you will find that we are getting multiple overlapping bounding boxes for it. But of course, we need only the best one, and that's why we are going to write the code to implement NMS. Now I will close this, and I will come back to this file, and let's read the first step. It says, extract all the bounding boxes, confidence score, and set the IOU threshold. Okay, what I will do here, I will create a function, say NMS, and it will take boxes, then confidence score, and then it will take IOU threshold. And by default, this value will be 0.5. Now in the object detection file, here we will call this function. So here I can write from NMS import NMS, and then I will go down, and here we are getting all the bounding boxes and confidence score. So I can call this function after this. And then I will give all the bounding boxes, then confidences, and then we can also set the IOU threshold if we want, otherwise we can go with the default value. Now I will come back to this file. Now the second part of this step says extract all the coordinates of the top left and bottom right corner in the separate variables. So let me show you the structure of the boxes. In the boxes, we are getting the top left corner of the first detection, let's say x1 and y1. And then we are getting the bottom right corner, let's say x2 and y2. And then we are getting the same things for the second bounding box. And so on. So what I need to do is to extract all of these four coordinates in separate variables. And for that I will write x1 equals to boxes, and inside this I will write colon, comma, and then I will give the column number which is 0 for x1. In the similar way I will write y1 equals to boxes, and in the bracket I will write colon, comma, and this time the column is 1. Then I will write x2 equals to boxes, colon, comma, 2. And then I'm going to write y2 equals to boxes, and this time the column is 3. Here the step 1 is complete. Now let's read the second step. It says calculate the area of all the bounding boxes, or you can say detections. So to find the area, here I will write area equals to, and to get the area I will multiply the bounding boxes width with their height. So for width I will write x2 minus x1, and I will multiply it with height, which is given by y2 minus y1. The second step is completed. Let's look at the third step. This step says select the detection or bounding box, let's say A, with the highest confidence score. So we need to find out that bounding box which has the highest confidence score. And for this, here I will write order equals to confidence score, and then I am going to use a Numpy function called argsort. And here I need to import Numpy. Now what this will do, it will provide me the indexes referring to the confidence score, and they will be arranged in the order in such a way that the index referring to the smallest confidence score will be at the first position, and the index referring to the biggest confidence score will be at the last position. Now just for understanding, let's print it to see what we are getting. So first I will print confidence score and then order. And here I will write this is confidences, and here I will write this is order. Now I will run this object detection code. I will close this, and here you can see the confidences and the order. Now if you notice, then you will find that the seventh element of this confidences is the smallest one, and it has the index 6, and that's why we are getting here 6 as the first element. And the third element here is the largest value, and it has the index 2, and that's why I'm getting the 2 in the last. Now I hope you understand the order. Now I will come back to this file and I will remove it, and here I will use a while loop, and then I will write len order greater than 0. So this loop is going to run as long as this condition is true. Now inside it I have to find the bounding box having the highest confidence score, and for that I need its index. So I will write idx equals to order, and from here we know that the index of the largest confidence score is the last one. So I can write here -1. So this will provide me the index of the largest confidence score. This is also the index of the bounding box having highest confidence score. Now to get this bounding box, here I can write A equals to boxes, and then I will give this index idx. Now after this, step 3 says remove this bounding box from the array of detections boxes and add it to the final detection list keep, and the keep is initially empty. So I need to remove this bounding box which has the highest confidence score. For this, what I will do is I will remove its index from the order list. So I will write here order equals to order, and in the bracket I will write colon -1. So this will remove the last element from the order list, which is the index of the bounding box having maximum confidence score. After this, we have to remove the coordinates of this bounding box from this variable. So for this, here I can write xx1 equals to, and then I will use take function from numpy, and inside it I will write x1, and then I will set the indexes to order. So this will provide me only those elements whose index is present in the order list. Now after this I will write yy1 equals to np.take, and then I will write y1, and then again the indices is order. In the same way I will remove the bottom right corners of this bounding box. Now after this step says to add this bounding box, which we also called A, in the final detection list keep, and the keep is initially empty. So I need to add this bounding box which has the highest confidence score in the keep list. So here I will create a list keep, and this will be initially empty. And here in the while loop, I will append the bounding box A in the keep list. Okay, the step 3 is completed. Now let's read the step 4. It says calculate the IOU of this detection A with every other detections in the boxes. So we need to calculate the IOU. And we know that IOU is given by intersection divided by union. So first of all, we need to find the intersection. So let me explain. Suppose this is our image and we are getting the bounding box here, which you can also call the bounding box A. And then we are getting another bounding box like this. We need to find this overlapping area, which is also the intersection. So for this, we need to find this top left corner and the bottom right corner. But the problem is we have two top left corner, this one and this one. So we need to tell our program that we need this one and not this one. So here in the program, I will write xx1 equals to np.maximum, and inside this function I will give the x value of the bounding box having maximum confidence score, or you can say the bounding box A. So for this I will write x1 and the index will be idx. And then I will give the x value of other bounding boxes. So I will write here xx1. You might be thinking that why I have used this maximum function here. So let me explain this. As I told you that we need this top left corner, and for this the x and y coordinates are greater, and for this they are smaller. And this is because x increases rightward and the y increases downward. Now in the similar way I will find the y coordinate for this corner. So here I will write y by 1 equals to np dot maximum, and then I will write y1 and the index is idx, and then I will write y by 1. Now after this I need to find the bottom right corner, this one. But again we have this corner and this corner, but we have the smaller values of x and y for this corner. So this time I will use the minimum function from Numpy. And inside this function I will write x2 and the index is idx, then I will write xx2, and then I will find the y coordinate. Now in order to find the intersection, let me show you. Here you can consider this like a rectangle, and we need to find its area, which is also the intersection. So for this I will find its width and height, and then I will multiply it to get the intersection. So for width I will write w equals to xx2 minus xx1, and for height I will write y by 2 minus y by 1. Now there is a problem. In case if we get the non-overlapping bonding boxes, then we will get the width and height as the negative value. Let me show you. Suppose we have this bonding box here. Then in this case there is no overlapping region, so we will get the negative width and height. And we know that the width and height cannot be negative. So what we can do is we will change this width and height to 0 if we get the negative value. And for this we will use the maximum function from Numpy. And we will provide the second argument as 0. So this will simply convert the weight to 0 if we get the other value as negative. The same thing I will do with the height. Now to find the intersection, I will write intersection equals to width multiplied by height. Now after finding the intersection, we need to find union. And according to its formula, we need the area of bonding box A, which has the highest confidence score. Then we need the area of other bonding boxes. And then we will subtract the intersection. So here I can write union equals to, now here we have already calculated all the areas, so we can use them. So for the area of the bonding box A, I can write areas, and then I will give the index, which is idx. After this we will add the areas of other bonding boxes which should not have the area of this bonding box A. So I need to remove this area. So for this I can write other areas np.take, and inside this function I will write areas, and then I will set the indices equal to ordered list. So this will simply remove the area of that bonding box whose index is not in the ordered list. Now I can use these other areas here, and then I will subtract the intersection area. Now we can calculate the IOU, and this is given by intersection divided by union. Now after this, let's read the next part of the step 4. It says if the IOU is greater than the IOU threshold for any detection in the boxes, then remove the detection from the boxes. So we need to check for each bonding box if its IOU is greater than the given threshold or not. And for this I will write here booleans equals to IOU less than IOU threshold. Now just for understanding, let's print it to see what we are getting here. Now I will run the object detection code. Now here you can see we are getting the array of the Boolean values. Let me explain this. So what happens is that for any bonding box, if this condition is false, we get the corresponding false. Otherwise we get the corresponding true. Now using this array of Booleans, I will remove those bonding boxes for which the condition is false. And for that, I will write here order equals to order, and for index I will pass this array of Boolean. Let me explain what this will do. Suppose we have the order like this. And then we have the array of Booleans like this. First there is true, then false, and then there is true. Now on running this statement, we will get the order like this. Notice that we don't have 0 here because the corresponding Boolean value was false. So actually we are simply removing the index of those bonding boxes for which the condition is false. And this will also remove the bonding boxes from our final list of detections. Okay, the step 4 is complete. Let's read the step 5. It says if there are still detections in the boxes, then go to the step 2 again. Here, by using the while loop, we have already covered this part. So let's read the next part. It says else return the list keep containing the final bonding boxes. So here in the last, I will return this keep list. Now if the code is fine, then it should work. So let's try it. Here I will store the return value of this function in boxes. Okay, we also need the filtered confidences. So for the confidences, I will do the pretty much same thing. First here, I will create another list, say keep confidences. And this will be empty. After this, I will come in this while loop. And here I will find the confidence score having the maximum value. So I will write conf equals to confidence score, and then I will give the index which is IDX. Now after finding this confidence, I can append it in the keep confidence list. And then I need to return this list as well. Now let's run the object detection code to see if our function is working. Now here's the result. This time we get only one bonding box with the highest confidence score, and all other bonding boxes has been removed by the NMS algorithm. So this is how NMS work. If you didn't understand something, then you can ask me in the comment section. That's all for now. Thanks for watching.